Oh, right, that's what.
All right, so you ready to keep going?
Oh, that's what it's.
So it's like we get swing.
So we've got our state machine, we've got state 1 coded. We can enter digits, we can update the display, and we're waiting for a plus sign. And plus sign right now just changes us to state 2. What else do we need to do though when we hit a plus sign?
Save.
Got to save our number, because eventually we're going to want to add it. So let's make another variable up here. Bless you. So this is the first number that we're going to work with, num1. I'll initialize it to 0 for no reason. Oh, by the way, you may have discovered this already. I've got all these imports in the top. I'm usually not interested in those. They have to be there as part of the code, but I don't really want to look at them. There's a little tiny symbol next to that first one. It's actually a minus sign in a circle. If I click that, it'll collapse all of those. And now that just shows up as an import, and I can see I skipped from line 1 to 14. That tells me there's stuff there. But this is just code folding, right? And it's just a way to visually reduce the clutter. All right, so we got a plus sign. Before we go to state 2, we need to save current number. Well, the current number, the text of it is in this string called current. But we want to actually save the number value as an integer so we can do addition, right? So, so do you remember how to convert from a string to an integer? Casting should work, but it doesn't. It's too much for it to do built into the language, so we have to actually use some code, something like scanf. But it's a method. Say again?
Something like integer.parse.
Yeah, exactly. So it's a method in the integer class, parseInt, and we can just parse current.
Is there like parse bool and parse double?
There's a parseInt that takes a string. We can also pass a string followed by a radix. So if we parse int current comma 2, it'll assume it's binary. I don't know what it does if it's bigger than 9, but it's not 16. If it's 16, it'll do hex. I don't know what it'll do if it's 17. If it'll just add a G to the end of it or what. I haven't tried it. All right, so this is our first number. Is num1, and then we set state to 2, and state 2 is the state where it says we just got the plus sign. So let's code up state 2. We got a plus. We're still looking at the old value on our display, but the first digit you hit should replace the display, right? So we want to replace whatever is currently on the display with the digit you just hit, assuming you hit a digit. So if we got a digit, let's just set the display equal to that text. And it's going to warn me here, unlike C, that it's looking for a Boolean and I gave it an int. Right, so what did I do here?
Equal. So
Yeah, I forgot to do 2 equal signs. I didn't forget, but I didn't type it. So it's warning you about that, right? And it won't compile and run unless you fix that. All right, so if we get a digit, we're going to change the display to show that first digit. And then we're going to say state equals 3, and we're going to return. And if you didn't get a digit, we won't do anything. So that's all of state 2. So state 3, we're entering our second number. And I'm going to rip off a lot of my code from state 1. Hopefully I didn't rip off too much of my code. Okay, there we go. So the thing that takes us out of state 3 is the equal sign, not the plus sign. So if text equals an equal sign, we're going to add them up. So let's save our current number in num2. Set our result equal to num1 plus num2. And then set our display to num2 as a string. And then we're going to go down to state 4. And we're going to return. And num2 has to be declared. Num2 can actually be local. If we're in state 3 and they didn't hit an equal sign, but they hit a digit, then we're just going to keep adding to the end of the display again. So same as before, if the display is a 0, we just replace it. Otherwise, we concatenate. And we're going to stay in the state and just return. That's the end of state 3. And then our last state is state 4. And here we just displayed the answer. And we're not going to do anything until they hit a digit. Right, so state 4, they hit an equal, we displayed the answer. And now we're waiting for them to hit a digit. The first digit they hit, we want to show that on the display and then go to state 1. So let's set text equal to text, set the state equal to 1, and return. But we're only going to do that if we've got a digit. So that's the end of state 4. And that's the end of our do key method. What do you think? Did we do an addition anywhere? Yeah, we do. So this should be a result. All right, should we try it? How many people think it'll work the first time? Yeah, me neither. Let's try it. 3 plus 8 equals 11. 44 plus 78 equals 122. I think it works. 6 plus 7 equals 13.
How would it be hit plus after you get your result?
It's going to ignore, so if I do 4 plus and I just hit a bunch of pluses, it ignores it, and if I hit a bunch of equals, it ignores it. When I say 9, and if I do plus, it ignores it, and lets me keep putting in digits. When I hit equal, it shows me the sum, and here it should ignore plus, and it should ignore equal. Right, and that's because we're in this state 4 right now, and state 4 is only going to move to state 1 when we hit a digit. So now we hit a 1 plus 1 equals 2. Bang.
But it'd be really easy to make it to where on like your standard calculator, you hit equals and it keeps doing the previous operation.
Mm-hmm, sure.
So you already have, as far as the computer's concerned, you already have your number 2 stored and your operator stored.
Mm-hmm.
So couldn't you keep just doing state 4 over and over?
Yeah, you could just keep going back to that state and it would do the addition and display. And if you type in 5 plus and you just say equals, I think it just uses number 1 as number 2.
Yeah.
And we could do that by just skipping directly from, I think, state 2 to state 4. Right, so when you structure it like this, right, this is where you're putting all of that logic in. And then the Java code is really implementing the state machine. And if you have a clean diagram like this, writing this code is fairly straightforward. Right, it's literally just what do we do in state 1, what do we do in state 2, and so on. Can we add a clear button to fix typos? The answer is yes. That's a hint.
Is it possible on some calculators, I mean, not physical ones obviously, but the clear button changes to is a clear when you're clearing, like, so say you've already put in your first operand and you put in your operator and you're typing in your second one, but you accidentally hit a 7, you want a different number.
Mm-hmm.
It's a clear button, but you hit it, and then it now gives you the option for all clear to start completely over.
Mm-hmm.
Is there a way to get these buttons, since they are digital, to change, like have that plus button change to a minus for some reason, or?
You mean change what the button looks like?
Yeah, the display.
Sure. Yeah.
Just have it, like, depending on what's going on, have it change.
Yeah, so if you look at the source code up in the beginning, we construct the button, we pass the string to the constructor, but at any time we could say button2.setText, give it a new string, and it'll go ahead and change the string accordingly. And because of the way that we've done this, if we change this to a 7, this actually becomes a 7 button, right? When we click this, by virtue of the fact that there's a 7 displayed, it will function like the button 7, right? As opposed to knowing that this is button _4 and saying if it's button _4, add 4, right? So we can get into some interesting sort of physical reprogramming of functionality by, yeah, yeah.
Could you have a calculator that, as they're trying to type, it just is randomizing?
Yeah, or you could shift it. You could like give them a chance, right? Just shift everything down 1 on each keystroke, and that would be fun to make, actually. It'd be fun to use. I think it would help you with like,
Reaction time and calculation.
I was gonna say Call of Duty, but yeah, basically.
Call it the drum keyboard.
Yeah, yeah. So let's make a clear button. And we'll just use this to correct one keystroke for now. So if you click this, we're just going to call our doKey method again. But in our doKey method, first thing we're going to do is see if you hit the C button. So let's think about our state diagram. So we're sort of going to start violating the nice smooth flow from state to state, but that's okay. Suppose you hit the C button. If you're in state 1, or you're in state 3, we want to take off that last digit from the display. If we're in state 2, you just hit the plus sign and you just hit the equal sign. We don't want the clear button to do anything. So let's just hardwire this. So let's erase the last digit. So we'll make a string called new display, and this should be equal to whatever your current display is. Well, there's another method you should know about for strings. It's called substring. And substring takes two arguments, a starting position and an ending position. And it gives you back everything from the starting position to the ending position minus 1. So edge case check. If your string is hello, the length is equal to 5. This is element 0, 1, 2, 3, 4. So if we do length, it'll take everything from 0 to 4. It will give us the whole thing. If we do length minus 1, it'll give us everything from 0 to 3. So let's toss a substring method in here. So current dot substring 0 current dot length minus 1. Alright, so if the text is C, we're going to see if we're in state 1 or 3, and if we are, we'll calculate a truncated display, set the text, and then we're going to return regardless.
And you can do like what Spencer was saying with like if you're in state 4, set it to 0.
Yeah, yeah. Alright, so let's run that. So 45 plus 784, oh, that was a typo. I meant 73. Oh, that was a typo. I meant 79. And right here, the clear button has no effect. But if I do 7 plus 9, let's clear that. And I got my... Look at all those errors, man.
Whoa.
But the source of this was out of bounds exception, string index of range, out of range minus 1. And then it caused all these other, well, this is where it came from. So what happens? If the length is equal to 0, length minus 1 is minus 1, and that's an illegal substring to try to take. So let's do the following.
Are you posting all this code?
I could. Should I?
Following along has been way harder than expected.
Yeah, we're going pretty fast.
Yeah, I'm totally on. It would be kind of cool if you could take this particular lesson and like segment it more in the
Yeah.
videos.
Yeah. Maybe I'll make some videos. So if current length is equal to 1, we've got a single digit we're erasing. I'm just going to display a 0, and I'm going to return. Otherwise, we're going to go ahead and truncate the length. So now we've got a 45. We can clear the 5. We can clear the 4. And then repeated C's are replacing it again with a 0. That's okay. So 7 plus 3 equals 10. So there's a clear button. So details notwithstanding, because there's a lot of details we've done already, right? And we're up to 200 lines of code. But again, most of this code we didn't write. Right, we've really only written one routine, which was do key, which goes from there down to there. So we're at about 70 lines of code. So details notwithstanding, is this making some sense? right? The central goal, the central idea here is this idea of state flow.
It's like the Turing machines.
Exactly. Yeah. Now what does a C button do on a real calculator? You hit it once and it clears the last digit, but maybe if you hit it twice it clears the whole number, right? So the action of the C button in that case depends on state. We would need a different state to say, hey, we've hit the C button once. And then if we hit the C button and we know that that's the case, then we could say, okay, clear the whole number. And we could make a state diagram with 8 states, or maybe 6 states, right? State 2 we got a plus, state 2.5 we got a plus, and we just hit a C, right? And then depending on what happens next, we could do one of 2 things. But we don't have to be engineering 250 people, right? We can sort of do things our own way, but that can get complex. But we could, when you hit a C, we could set a local Boolean variable, well not local, but a Boolean variable to just indicate that we've seen C, that was the last keystroke, and then in here we could check that Boolean, and if it's set, we could say go ahead and clear the whole display. And if it's not set, we could set it here, and if you don't hit a C, we could clear that flag. So we can do other things. But those are our details. All right, so one more embellishment. How hard would it be to add more functions to this? To add multiply, divide, and subtract.
Not very hard. More states.
3 more lines of code.
Not as hard as the OEP or state.
As hard as the ODP. Except I'm going to put my buttons in weird places.
You should put one line very far right there.
Okay, we'll put division over here because we don't really want you dividing. Because that always gets us into trouble.
Ooh, what if you divide by 0?
Yeah, that's a good question. We're going to find out really soon.
It gives you NAND on the calculator.
It's a 0, but it's more because you have to clear all of it. Just clear.
No.
That's the thing I've seen on that.
Just wanted to get
Fraction class with this calculator.
I think this calculator should have a modular button.
Should I have, oh yeah, that would be good.
How about a tangent?
A 10.
Yeah, you can code. Well, if we could do sine because it would just always be 0 unless it's 1 because it's integers. All right.
Need a fun tangent. You call that one?
We're gonna make our divide button red because it's like dangerous, right? All right. So so we need to do key as usual. And I'm in VI, so I can just hit a period and it repeats my last operations. That's why I'm inserting that stuff so quickly. Well, so what's different here? What's different on our state diagram?
State 2.
All right, we can transition on any of those action keys. And over here, it's going to tell us that we got something. But we're going to want to save that operator. That's our ODP, right? We want to remember that eventually we're going to do an add, subtract, multiply, or divide. And then down here, when we say update the display, we're going to use the saved operator. So it's surprisingly little code, you're right. They are. That's weird. Yeah. I should fix that.
It's not a mouse.
Makes you wonder what I'm thinking. All right, so there's our compositive statement. So if text equals plus, minus, times, or divide, we're going to do the parse int. Save our num1. Save our operation in a string called saveOp. And then there's only one other thing we got to do, which is right here. Instead of adding num1 and num2, we have to do some sort of operation on them. So let's say result equals doop num1 num2 saveOp. So we'll do the right operation. And so we need a doop method. Doop. All right, well, let's do a switch here since someone asked about a switch anyway. And we don't want to switch on a string, we just want to switch on a character, but we know that op is a string with one character in it. So let's switch on op.character at position 0. So that'll be a character, and that's safe to use in a switch statement. So case single quote plus. And we'll just return num1 plus num2. And we'll do the same thing in here. And I should never have something that's not one of those, but if I don't put in my return 0, it will complain that I don't have a return value. That's one of the things I find is slightly annoying. Because I know I'm not going to get down to this line of code, but it doesn't, so we'll return a 0 there. That may be all we need. Let's try it. So 2 times 4 equals 8. 7 minus 99 equals minus 92. Cool.
4 divided by 0.
4 divided by 0.
That's mine.
Oh, equals. There we go. And we got all these errors. Blah, blah, blah. Ultimately, arithmetic exception. But we can still keep going. There we go. So what do you do about the divide by 0? Yeah, probably easiest is a try catch. So in that do op, we could just put in a try catch, and if we got a problem, we could just display something. Nan or error. But then we're going to have to change some of our states because some of these states look for like a 0 to start replacing with a digit, so we need to check for 0 or NaN maybe. But we could just crash the program or something. Delete your files, I don't know.
Is there a way
Call
to
the
get,
user an idiot.
Yeah.
is there a way to get the division key to be the horizontal bar with the 2 dots?
Oh, yeah. So we can put icons in here. And I haven't done this recently.
Would it be just like an image, and then you, in the code, it would be like icon 1, 2, 3?
Yeah, so we can click on icon, and how does this work? Absolute path and file system. Never use in real application. That's us. But I gotta find some icons, and I don't know where to find those.
Just go on the internet and download the JPEG or something.
Yeah.
And you get to use that division symbol that you've been wanting to use for years. That's been sitting on your computer.
There's probably a font we could change to, like Wingbats or Wingdings or something that would have the divide symbol also.
Just use Unicode and use that.
There you go. Power motion.
See if we can pick up a virus in the middle of class. That'll be good. Okay, we'll do the palm trees.
You could have a lesson on how to fight a virus.
Yeah, there you go.
How to hack into the provider and give them back their virus.
All right, so downloads. Man, I got too many downloads.
Just get that somewhere.
But that didn't seem to do anything. That didn't work.
Try maybe now getting rid of
I'll figure it out. I'll let you know on Wednesday.
There's the division symbol, it's down now.
Yeah, I got rid of the text. I'll play around with it. I'll post something or let you know.
Do you think the color has anything to do with it?
Well, yeah, but I can't get rid of the color. I was gonna set the color to go away, but
That's like selected icon.
that should be the one that we just.
2 down.
Maybe an icon when it's
Selected.
when you click it. But we can make the same one. No, we don't want to do a lab report. Class resource, no image, default image. Okay.
Maybe resize the box. Maybe it's too small to show it.
That's another good idea.
That was the darkest. Look at my shit table.
All right, there's an ungraded homework. Figure out how to put an icon on a button. It's easy to do. You just got to find the right combination to hit. I don't remember what it is.
Biggest division button.
Yeah, right. Divide. So, questions, comments, ideas. This is a pretty standard way that we're going to be working with code from here on out, because we're working with graphical interfaces, and these things tend to be event driven, right? We don't do anything until a person hits a button. And what do we do then? Well, I don't know. It kind of depends where we are in the system. So your next PA is probably going to be a tic-tac-toe game. And think about tic-tac-toe.
It's always a draw.
Say what?
It always ends up being a draw.
It could. Depends who goes first. If the human goes first, you might lose. So yeah, so you draw a playing field, right? And let's say the user clicks right here, and you do some sort of arithmetic to figure out, okay, they clicked in the upper left square. Well, what are you supposed to do now? It really depends on where you are in the game. If this is an empty playing field and you just started, you want to put the user's mark here. Is that an O or an X? Well, it depends on what button they clicked over here saying I want to be O or I want to be X. So they selected the X button, so you're going to draw an X. But if there's already a mark here and they click, you don't want to draw an X there, right? Because that makes it easy to cheat. So in that case, you need to do something like, you know, say pick a square that's not occupied. Or if the game has already ended and the computer has won, and now they click here, you don't want to put an X and say, hey, the user won, right? Because the game has ended. You don't want to do anything until they hit the button that says start a new game. So it's the same case as the calculator, right? Same action, same place in your code, same arguments to your code saying this is the XY position where you clicked, but what you're going to do depends on what's happened in the past. It depends on, in this case, the state of the board and the state of the game. And so our PAs are going to sort of have this behavior, and it's inevitable when you're working with graphical interfaces and you're not just polling to say, you know, wait until they click somewhere and then do something. You're just kind of coming in the middle of nowhere, and all of a sudden you got to know what to do. And how many people have done 270? Most of you, okay. If you think back to 270, your interrupt lab, you had lights that were blinking. So 3 lights blinking in order. And when you hit an interrupt, it was supposed to suspend that blink process, turn on an LED for like 2 seconds, and then when it's done, go back to blinking, right? And the real tricky part of that, the whole thing was tricky, but the real tricky part was being able to have nested interrupts. So that while you're doing a low priority interrupt, you generate a high priority interrupt, respond to that, and then go back and finish the low priority interrupt, maybe get another high priority interrupt, respond to that, go back to the low, and then go back to your original sequence, right? And you couldn't do that if in your interrupt routine you just sat for 2 seconds holding an LED on, because interrupts were blocked. So the fancy way to do that part of the lab was to build a state machine in software, right? And remember, for example, that right now we're holding this LED high, right? And then when another interrupt occurs, right, you're not sitting inside that routine, you're just in a main loop, just sitting idle. Okay, same thing that swing is doing when it's just sitting there waiting for an event. But then when you're done holding that LED high, you look at your state variables and you say, okay, I'm supposed to be displaying interrupt 1 for another 0.6 seconds. And so you go back to that and you finish it out and you continue blinking. Okay, so this is something that you'll encounter repeatedly, this idea of state-driven code and state-driven programming. So I can post this code on the website from Canvas, but with a disclaimer that it's just going to look like this, right? So it's 310 lines, and it's mostly, you know, the stuff that was written for us. And if you were to take all of this and pop it into Eclipse, right, you should be able to reproduce it. But it will help you with like this basic setup.
Well, you're gonna want to put your label back on your division button because otherwise it's not going.
The blank button is divide.
Right, but when doesn't it grab that?
Oh, but it grabs that, you're right. Thank you. Cool. That's pretty righteous. So 9 divided by 3 equals 3. Well, that was boring. 9 divided by 2 equals 4. Good. Yeah. Did not blow up. Nobody got hurt. What did we call this thing? Super Number Cruncher 5000. you sure you want to paste 8,387 characters? Do not ask again.
Okay, good. Wait. So we're signing
All right. All right, so that's up on the website.
Where you put it?
On Canvas, there's a link to the shared area, but you can get there directly. linuxengrcs.com, twiddlenick/shared, and there's 223, so it's under there.
Can any of us post to this?
I don't think so.
I saw it's called public.
Yeah, so it's publicly readable,
Uh,
but you gotta log in. And it's got other stuff on here too.
Were you putting it under?
223/calc.
Oh, okay.
Yeah. But that's the directory that Canvas takes you to. All right, so that's just an example, right? We could do other things. We could make it arbitrarily fancy, but it's the basic idea of responding to events in some sort of way and using a notion of state to control what we do. So we'll play with that a lot in Pt2. All right, other questions? So lab 2 I graded, and that looked really good, so I think everybody got 100 on lab 2. I wanted to make two comments. One, make sure you include your signature sheet, okay, your sign off saying that it works. Make sure you include that somewhere in the end, like at the end of the report, right? Second comment, be thinking about lab reports, what the purpose of a lab report is and what you want in a lab report. And I'm not as picky here as I am in 250, 270, okay, because we're really doing this just as a way to get some hardware experience with Java. But spend some time making an actual lab report. I got some one-pagers or some half-pagers in a few cases that said something like, in experiment 1, we made an LED blink in response to a keyboard. Everything worked fine. In experiment 2, it turned on and off. In experiment 3, we changed the time to be variable. That worked fine also. And then there was a sign-off sheet, and that was the whole report. Okay, so with the sign-off sheet, I can see that you got the thing to work. But remember, the idea of doing a report like this is that other people can use that report to see what you did and to try to reproduce your results. Okay, and this is more, you've got a bacteria on a microscope slide and you hit it with an enzyme and something happens, right? It's a little goofy sounding to think about this with Java code, but you can apply the same model. You hooked an LED up in a certain way to this Pi device, and you wrote some code and compiled and ran it, and this is what happened. You typed in a 20 and the LED blinked real fast. Blanked. So somebody reading that report should be able to reproduce what you did and get the same result. And if 20 people follow your steps and none of them get the LED to blink, they can say, you did something wrong. We don't believe you can actually make an LED blink, right? Or 20 people do it and they get the same result, and now the body of knowledge has been extended because we know this new property of LEDs in Java code, right? Or bacteria or whatever. So you can assume the person reading your report has comparable level of knowledge to you. Okay, they know what Java is, they know what a Raspberry Pi is, they know that they've got to log in and they know how to log in and so on and so forth. But don't assume that they know that you use pins 14 and 16 unless you tell them that, right? List your whole code so that they can type in that code themselves and see if it works. And for the first time that you use this code, it's not a bad idea to include how you compiled and ran it, because you got to do that class path switch, and that's a little different, right? And I would say on lab 3, you can kind of assume that they've done lab 2, and so they know how to compile and execute Java code to use the Pi4 package. But you still want to have your code in there. And when you're putting code in your report, instead of doing a screenshot of the PuTTY window, it's easier to just copy your code with the mouse and then paste it into Word or whatever document you're using. Because that puts it all on one page. I got a lot of PuTTY windows, but the code was cut off. And sometimes I get 5 PuTTY windows with 24 lines of code in each window. And you got to kind of paste it together in your mind and so on. And you can just drag over the mouse and it'll scroll automatically. So you can go up to the top and start dragging and grab 1,000 lines of code if you want, and then just paste it into a document.
Did you ever fix the BI event for Raspberry Pi?
Yes, I posted a procedure for taking care of that. And the procedure is basically using the stty command to tell Linux how many rows and columns. But to make that work, you got to know how many rows and columns PuTTY is displaying. And you can do that from the properties window. So the whole procedure was resize your window, go into the settings and see the rows and columns, and then type reset, and then type stty rows, columns. Yeah?
So did you leave comment for the lab report with some problems that you noticed?
Most cases I didn't. If there was some particular issue or I just felt chatty at that moment, I might have. But in general, if I didn't leave any comments, don't worry about it.
Right, because I missed the first lab and this one I did not see the comment. So
Okay.
I'm wondering,
Yeah.
keep going what I'm doing or
Yeah, yeah.
So,
Yeah, it should be fine. You got 100%, right?
yeah.
Yeah, so you should be good. All right, good. So where are we going? So Wednesday we will talk about PA3. Man, the quarter's flying by. This is crazy. Wednesday we'll talk about PA3. We'll talk about any ODP issues you ran into, but you should be totally set for today's and tomorrow's ODP. And then we're going to pick up some details. We might talk about statics, finally, and see what public static void main is all about. A couple of other odds and ends I want to pick up. And then we're going to start talking about threads. So we'll probably get into that on Wednesday, and we'll do it more next week, and that's going to tie into the next lab that you're going to do. So one of the nice things about Java is it makes it really easy to run multiple processes simultaneously. And in C, we talked briefly about fork and execl and a few system calls like this that we could use to create another process. But it's a really kind of painful mechanism to use. You're really kind of working at the lowest level of process creation. On Java, it's really, really easy, right? And it's all bundled inside classes, so it's got the same look and feel as strings and everything else that we've been dealing with, rectangles and fractions. And we can create multiple threads and have them both executing at the same time. And that's already happening behind the scenes with swing classes, but we're going to use that deliberately to do some things in some future assignments. So we'll talk about threads, and that'll take us into more general topics about multi-threaded programming. We got to come back and talk more about trees at some point, and we're still going to balance trees because we didn't do that in 222. I have not forgotten. So we'll spend some time doing some tree balance, probably as a counterpose once we're in really deep with this stuff. I'll let you chew on that stuff for a while, and we'll come back and do some more pure data structures outside of Java. So we got good stuff coming down the road. All right, let you out 2 minutes early. Have a good day. I will see you next time.